Good day, it's Tony Fortunato from the technology firm. Today I'm going to walk you through troubleshooting at the physical level. Myself and NetworkDataPedia are putting on a series of videos and articles of knowing your network. So this is the physical level presentation. Let's jump right into it. So a network is not a pretty fluffy cloud. As you can see here, all this stuff. Everything on this screen and a bunch of other stuff I couldn't fit on there is responsible physically for passing the data from one point to another. So every single connection point, cable, patch panel, switch, everything is responsible for that. So you need to understand how to troubleshoot, baseline, document, and test all those various components. You're only as fast as your slowest link. So when we talk about troubleshooting servers, PCs, anything, printers, it's important to understand the interface speeds and their limitations. And I've got everything here going as far back as even serial and parallel ports, USB 1, 2, that sort of thing. And you're going to see why in a moment, why this is incredibly important. So as you get more and more stats and numbers on other interfaces and drive speeds and whatnot, you can just throw it all in there if you'd like. And here's an example. So we have a gigabit Ethernet NIC. It's an adapter. So it's USB to Ethernet. And they're both gig adapters. And one was about $5 cheaper than the other. And why was it cheaper? Well, take a look. USB 2.0, that's why. So USB 2.0, that interface goes from 120 to 300, whereas a USB 3 would go up to 5 gigabits per second. In some cases, it's probably more. And actually, when you factor it all in, $5 change shipping and all that is about $9, right? So the USB device was about $9 more, and obviously it is the better deal. Now people will counter USB 2 devices, will have buffers and whatnot, but why even deal with that? Just spend a few extra bucks, get the proper adapter, and you'll be good to go. The other question, of course, is will your system, the front side bus, memory, software, and all that jazz, will it be able to handle multiple gigabits worth of traffic? So a little bit about your tools. So field test tools, right? And it's real simple. This is a bad solution where you have to carry around keyboard, mouse, monitor, Honda generator, whatever you got to carry around to make things work. And I've seen people do that. They drag desktops around with them on a cart, right? It kind of reminds me of high school when you bring in the AV guys, bringing the projector around, that kind of thing. A better solution, people are gravitating to notebooks, laptops, netbooks, Chromebooks, all that kind of stuff. And now even Android tablets are being used for troubleshooting. Just make sure you know the limitations of that device. And lastly, the best solution is to get a actual specific purpose tool for that job. So if you're going to test a cable, get a cable test tool, that kind of thing. And these are not that expensive. They used to be like 20, 30 grand, and now just for a couple of grand you can get a handheld tool. So a little bit about errors in the physical level. If you do have a problem at the physical layer and a packet doesn't get to the other end, it's important to understand what that behavior is going to look like. So we talk about retransmissions, and that's how you document this kind of problem. And the protocol isn't designed to retransmit, right? If the protocol isn't designed to retransmit, the packets are lost. And that's something like a UDP packet, ICMP, those types of packets will not get resent by the protocol. The application needs to figure out, hey, something's missing, I need to resend stuff. Now, if you look at this example, we've got a laptop, we've got a server, and we're sending our packets, and it's important to understand that I'm missing a packet. So now what? So now I got to resend. How long is that going to take? Well, it depends on the operating system, depends on the application. It can go as low as 200 milliseconds, maybe even lower, as high as 8 seconds. And I've seen 30, 60, 50, 45, anywhere in that range. But it takes a long time to figure out something happened, and then it has to resend stuff. So as soon as you hit a retransmission, things typically slow down. If we want to look at this from a different perspective, we have our tools at either end, the laptop or the server side. You'll see two totally different reports from the exact same tool. From the client side, we can see you sent stuff. This one didn't get through, so I had to resend it. So from the client side, guess what? I have a retransmission. Obviously, I resent that packet twice. From the server side, though, I see my packets coming in. I do not get that packet, obviously, and then I see the retransmission. So from the server side, it looks like the client is slow. It says 201 millisecond delay, because of course he did not see that retransmission. So make sure that you have your capture tools from the sender's perspective. So if I was to download a file from the server, I want to capture from the server side. If I'm uploading, I want to be on the client side. Now, if you're using something called a TCP SAC, a selective acknowledgement, then in the trace, you'll see things like SLE, SRE, that's your selective left edge, right edge, and that's giving you a clue that something happened and that things are being retransmitted on the wire. So now here's a phone. We've got some UDP stuff going on, and it's important, again, just to highlight that things are going to get dropped, and if they are dropped, then the application needs to figure out what to do about it. Now with audio, video, that sort of thing, there is no retransmission. You don't want that piece of audio coming back later into the conversation or that video coming back into the stream later. It just drops and you get a little blip or a drop in the audio or some pixelating on the video or a jitter, whatever. But you need to understand why that video and audio behave that way, right? That'll help you troubleshoot the problem. If you have some fiber optics, please do not use your shirt to clean your fiber optic cables. Do not kind of breathe on it, do the old and then wipe it on your shirt. This is kind of what the fiber looks like when you do that. There's a picture of that, and you can see the actual fibers from your polyester cheap shirt and little gobs of your breakfast stuck all over the end of the fiber. Down here we've got some clean fiber, and even though it's clean, you take a look, you can see there is some manufacturer defects with that cladding. And on the right side here, you'll see that one side, the cladding is thicker than the other side of the same fiber core. What that's going to do is give you a really interesting problem. If the cable is short enough and the signal is strong enough, no problem. But as soon as that cable gets longer or the signal gets weaker, then you have a problem. Lastly, if you do have fiber optic equipment, please find those dust caps that you lose and put them back on the equipment if you're not using the equipment or the cabling. Now on the right hand side, I'm giving you some examples of some tools that you can use to visually inspect your fiber. And the bottom tool is an fiber optic cleaning kit where you can actually clean your fiber properly. This side is titled What Could Possibly Go Wrong, because we all know things do. And on the left hand side it's a good old motherboard, and you can see this line of green is where I've dragged my finger across the board to take the dust off of it, and that dust will accumulate over time and cause the board to fail and overheat. On the right hand side you can see an RJ45 copper pin here, and the center one is kind of green. That's oxidation. And that's important to understand when you have equipment in, I'm going to call it environmentally unfriendly areas. A lot of moisture, that kind of thing. So what you might want to do is make sure you have the proper switch for that, the proper cables for that. A little trick, you can use some non-conductive gel, and you can just kind of put it on the cable and plug it in. There's all sorts of names for that, dielectric gel and that kind of thing. You'll find that in the automotive section, marine, electronics section, that kind of thing. All right. Excessive dust on the motherboard will trigger a heat alarm if your system does that. Or you'll notice there's a lot of SNMP reboots from that same device. And that copper port, you'll probably see a lot of CRC errors. If you do have some cabling issues, sometimes you cause them yourself. Down here in the corner you can see that cable is pinched in the door, not a good thing. Up here you can see there's an RJ45 female to female coupler to extend some cables, and the technician simply wrapped it with electrical tape because that'll keep all the bits from leaking out. And down here we can see an actual antenna, and this antenna is got some electrical tape that's been a kind of, I'm going to say, last minute repair job. And if you take a really good look at the antenna, you can see there's a lovely arc, you know, like kind of like somebody spot welded the side of that antenna, so probably not in good shape. And then of course, if you do log into some equipment, in this case a Cisco switch, you'll find all sorts of clues. Things are not good at the physical layer, including input errors, CRCs, that sort of thing. Even collisions can sometimes result as a physical layer issue. This is one of my favorites. It's from a real customer site. It's called What Else Could Possibly Go Wrong, and this is human error. You can see there's a lovely ladder that's up against the power switch of the main power shutoff for that communications room. And every once in a while somebody would grab the ladder and that little switch would flick down, and they don't know what that switch really does, and they'd flick it back up. But in the logs you would actually see it says detected reboot. If you have a system that does that, either polling or receiving a log, that would do that for you. Lastly, got a bit of a news flash for you. Network challenges have changed in the last few years. Originally we used to fix things that failed. Now they're slowing down or other odd performance issues. Many tools and methodologies have not kept up with the time, so that's your job. Your job is to find out how things work in your environment, what the issues are, and what tools you would use to fix that. And don't forget, just because it works doesn't mean it works well. So last note, thank you for your time. Now get to work. Have a good day. Bye for now.